Welcome to another tutorial on our healthcare data analysis playlist. In our today's video, we'll be looking at how I analyzed hospital readmission dataset. So if you could see, I saved this notebook as hospital readmissions. Okay, let's go ahead and close that up. I started with giving a brief background and introduction about what the project is about. So for the background of this project, we are assuming that we work for a consulting company that's helping a hospital group better understand patient readmissions. So the hospital gave us access to 10 years of information on patients that are readmitted to the hospital after being discharged. The doctors want us to be able to assess if initial diagnosis, number of procedures, or other variables could help them better understand the probability of readmission for a patient. They want to focus follow-up calls and attention on these patients with a higher probability of readmission. So that's the background for our project we'll be looking at today. So some of the objectives we'll be tackling: we want to create a report that covers the following. 1. What is the most common primary diagnosis by age group? Second is, some doctors believe diabetes might play a central role in readmission. So we want to explore the effect of a diabetes diagnosis on readmission rates. And lastly, we want to look at on what groups of patients should the hospital focus their follow-up efforts to better monitor patients with a high probability of readmission. So those are our objectives for this project. So the next thing I did was to look at our data set, which we'll be using to tackle this problem. So these are our data sets, and our data set contains 10 years of patient information. In the file, we have age, which is the age of the patient. Then we have another column which stands for the time in hospital, the time the patient has spent in the hospital from 1 to 14 days. Then we also have N_procedure, that stands for the number of procedure that has been performed during the hospital stay on that patient. So we also have number of lab procedures, number of medication, that's number of medication that have been administered during the hospital stay of the patient. We also have number of outpatients, that's number of outpatient visits in a year before a hospital stay, that means before the patient was admitted. We also have number of patients, which signifies number of patient visits in the year before the hospital stay. They also have emergency, how many times this patient has been brought to the emergency room. We have diagnosis. Diagnosis 1 stands for the primary diagnosis. Diagnosis 2 was for secondary diagnosis. Diagnosis 3 is any additional or secondary diagnosis. Then we also have a column that shows the glucose test of the patient, A1C test, then change. We also have a column for change that signifies whether there was a change in the diabetes medication or not. Then we also have a column that's diabetes med, that stands for if the patient was prescribed with diabetes medication or not. And our target variable, which is the last column, readmitted. So that column is going to stand for if that patient was readmitted at the hospital or not. The next thing I did was to import the modules and packages I'll be needing to tackle our problem. So the first thing I did was to import pandas as PD. I also import numpy as NP, matplotlib.pyplot as plt, and cborn as SNS. I'll be using those two libraries to create visualizations for our data. So when I was done with that, the next thing I did was to now read in my file into my Jupyter notebook. Okay, so I used the pd.read_csv and the part where my file is saved on my computer system. So you can see is under the download location on my computer, and the name of this file, which is hospital readmission.csv. Okay, So the next thing I did was to look at the first 5 rows of this data set using the dot head method. So you could see age column, time in hospital, number of lab procedures, etc. So those are the first 5 rows. So if you look at this data set, you will see that our data set needs cleaning. We have a lot of things, to clean on this data set. You could see, if you look at our age column, you can see some values that are not right. You can see 70 to 80, and which is not supposed to be so, right? So we're going to be cleaning this data set. So I went ahead, and before I did the cleaning, I did some quick exploration of my data set using the .info method. I wanted to look if I had any missing values, null values, and all that. So looking at the data set, there was no missing values. You can see that we have 25,000 rows of data, and for each column there was no missing value for all the columns. They were all 25,000 rows of data. Okay, so the next thing I did was to rename some of our columns, like the diagnosis column, which came in as dag 1, dag 2. So I renamed it. For dag 1, I renamed it to primary diagnosis. Dag 2 was our secondary diagnosis, while our dag 3 was our additional secondary diagnosis. Then I also renamed our change column to med changed, as if any medication was changed or not. And I renamed our A1C test to HbA1c test. Okay, so I added the in place equals to true, and so that I don't go ahead and give this data set another name, so I just had to use the in place equals to true. And checking the first 5 row of this data set, you could see that our changes has been affected. So if I scroll this, I can see primary diagnosis, secondary diagnosis, the additional secondary diagnosis, HbA1c test, then and also med change. Okay, so you could see that we've done some cleaning on the name of our columns. So another thing I did was to convert the age columns to categorical data. So if you look at our age column, they did not come in a specific value like 70, 25. It came in ranges 70 to 80, 50 to 60, like that. So since I cannot pick a specific age for each patient, I decided to categorize them. Okay, so for 70 to 80, I categorize this as senior old age. For 50 to 60 as late middle age. For 60 to 70 as mid old age. For 40 to 50 as early middle age. 80 to 90 very senior old, and 90 to 100 as centenarians. Okay, so those are the categorization I did, and I use the dot replace method to just go ahead to do that. So technically saying replace these figures with this text here. Then when I was done with that, I also convert the column type to categorical data type. So since I've already categorized each age into various names, I had to change that column type to a category data type, and it was easy. I just had to use the as type method to do that. Okay, so it's a straightforward process. When I was done with that, I also used the type to check my changes if it were affected. And if you could see here, after checking the type of that column, the age column, you can see it appears as category. And you can also see, if we look at the age column now, you can see the other new column which I created, the age underscore cat. So you can see the various category for each age. So now, since my changes have been effected, the next thing I had to do was just to drop that previous age column, since it's no longer useful, right? So all I had to do, this age column that's no longer useful, I had to just go ahead and drop this. So I used the dot drop method to do that. The next cleaning I did was to change the data type of each column to their correct or their accurate data type. So for columns like medical specialty, primary diagnosis, secondary diagnosis, additional secondary diagnosis, glucose test, you can see medical change, diabetes medication, readmitted. I converted the data type to category, since they are all categorical data, and I did that using the .astype method. So let's scroll down. The next thing I did was to check for duplicates in my data set. So I used the .duplicated method and adding also the .sum method, so that I can check for the total number of duplicated values in this data set, and we had 0, meaning there was no duplicated value in our data set. When I was done with that, I went ahead to view the unique values of each column to check for inconsistent data, because we have a whole lot of data, like 25,000 rows of data, so there might be some inconsistent data. So for me to be able to view the inconsistent data within this data set, I use the unique method to identify those unique values, so that I can see which one is inconsistent among them. So for me to be able to do this quick and easy, I use a for loop. So you could see I for loop through each columns of our data set, and I asked it to print the column name and also the unique properties of that column. So you could see for time in hospital, these are the unique times. So if there was any repeated value or inconsistent value, then I would have been able to identify that value easily. So you could see for number of procedures, number of medications, medical specialty, we can go through that. For medical specialty, you see we have missing, order, internal medicine, family general practice, cardiology, surgery, emergency/trauma. Okay, and it shows us that we have 7 categories. Okay, so there were no inconsistent data for medical specialty. So same thing, you just go ahead and go through primary diagnosis, and you can see we have circulatory, orders, injury, digestive, respiratory, diabetes, musculoskeletal, and missing. So there were also no inconsistent data for our primary diagnosis. So that was what I did. You can just go through it one after the other and check. If you have any consistent data, you take note of that, so that when you are doing your data cleaning, you incorporate that in cleaning your data. So after my data cleaning, I gave a brief note in regards to those things I have done. So I didn't just clean my data and move to the next stage, but I gave feedback on what I have done. So I said the data set contained 25,000 rows and 70 columns, and these were what I did to clean the columns. So the first thing we did, I stated that there were no missing or duplicated data in the data frame, and also the next thing I did was to clean the name. So I stated that the columns that their names were DAG 1, DAG 2, DAG 3 were renamed as primary diagnosis, secondary diagnosis, additional secondary diagnosis, and all that. Okay, so I also stated that for the age column, there were some wrong categorization, so I had to recategorize it correctly. Then I also stated lastly that the data types of the columns were accurately converted to their proper data types. And I didn't just end there. I also stated that at the end we still have our 25,000 rows of data, and 17 columns. Okay, so in case we had dropped down some rows of data with this, now I would have been able to identify, okay, initially we had 25,000 rows of data, but when we were done cleaning it was now 20,000. But since there was no rows of data that were dropped, or there was no columns of data that were dropped during our cleaning, you have to specify that, okay, initially we had 25,000 rows and 17 columns, and at the end of cleaning we also add 25,000 rows and 17 columns of data. So that's for the data cleaning. And after you've cleaned your data, the next thing you are going to go ahead to do is exploratory data analysis, which is commonly known as EDA. So for our EDA, the first thing I did was to describe our data set. I wanted to see what our data set is about. So to do that easily, you can use the .describe method to do that. So I use the .describe method to explore the numeric columns of this data frame. So from this we can see that the average time in the hospital is 4 hours, right? And the average lab procedure a patient has carried out is 43 lab procedure. Then you can also see that the average number of medication taken by a patient is 16. Average number of outpatients, the average number of inpatients, then the average emergency. So you could see that using the .describe method we can get a whole lot of information. So we can see the minimum time a patient has been in the hospital, the maximum time a patient has been in the hospital. We can also see the 50%, which is the median. The next thing I went ahead to do was also to use the .describe method on our categorical columns, and to do that I have to add the exclude argument and set it to be equals to mp.number, okay, so that it can give us information regarding our categorical column. So we could see our top value for medical specialty was missing, and it occurred on 12,382 times. It also shows us that we have 7 unique medical specialty, and you could see that for all the categorical columns. Okay, then the next thing I did was to visualize my information above for easy understanding. So aside from this table, I want to create a graph so that we can easily just look at this graph and understand what our data is all about. And to do that I defined a function and called it the plot underscore cats underscore count function, and I use the for loop to loop through all our columns in this our column array which we've created using just the names of our categorical column. And I specified that I wanted use the cbon.canplot on each column. So sns.canplot, and our x was going to take in c. When we are for looping through each column, that's s will be each column in our data when our data is equals to our hospital or hsp underscore df. I also set the title to bc, which is a variable looping through each columns. Then I did the plt dot show. So if you look at our data set now, you can see our age category, and you can see for our age category the most occurring is senior old age. Okay, so let's see our data set fully. So you can see that the most occurring is senior old age, then followed by the mid old age, followed by late middle age, then very senior old, early middle age, and the list is centenarian. So the next visualization is for medical specialty, and you can also see the information we have missing as the IS, and we have internal medicine as the next in line. That's just what our visuals can do. In just looking at it at a glance, it gives you enough information you need to know regarding that particular features or column. Okay, so I'll just go ahead and minimize this so that we can move along. So when I was done with that, I also added a feedback in regards what I was able to get or understand from visualizing that data set. So before I go ahead and say that, the next thing we did was to look at the most common primary diagnosis by age group. And for us to be able to do that, I just had to use the dot group by method. So I grouped by age category, and I want to see the which primary diagnosis is most common for each age group. Okay, so I use the dot values count to count the occurrence of the primary diagnosis, right? I normalize to be true so that we can get a percentage, and sort was equals to true. I also created a data frame from my analysis to make it much more compact. Okay, so if you look at our table, from this table you can see we have our different age categories here, and we have our primary diagnosis here, and our question, we want to answer the most common primary diagnosis by age group. So for centenary, you can see 30% for circulatory, and which is technically the highest. So for centenary, the most common primary diagnosis for centenarian age group was circulatory disease, while for the early middle age, if you look at our data, you can see that the most common year we have is others, have coming with about 29%. We can also look for that of late middle age. The most common we have here is circulatory too, which was about 28% also. So you can just go through the table and look at the percentage of disease for each categories of age. Okay, so with that you'll be able to get the most common occurring for that particular age group. The next thing I did was to use a graph to be able to show this. Okay, so that instead of going through a table and trying to figure it out, you can just look at your visualization, and it will be easy for you to see. You can see for centenarians, the most occurring year was let's go ahead and scroll down so that we can see the various labels. So you can see we have circulatory here as the most occurring for our centenarians. Okay, if you look at each visualization and probably scroll down a bit, you'll be able to easily see each disease condition that was most occurring for each age category. So at the end of it, I just had to give my feedback in regards what I was able to analyze from the data. I said from the table and graph above, we can see that circulatory diagnosis was the most common primary diagnosis across the various categories of age, outside early middle age, where others as a diagnosis category came first, and circulatory diagnosis was the second. Okay, so you could see I gave my feedback at the end of this analysis. So the next question I want to answer was to explore the effect of diabetic diagnosis on readmission rates. How does a patient having diabetes affect readmission rates? So to do that, I decided to use a pie plot to see the distribution of health condition for the various diagnoses. So for the various diagnoses, we have our primary diagnosis, secondary diagnosis, and additional secondary diagnosis as our columns, right? So I want to see for each of these diagnostic column, I want to see how are each various diagnoses distributed along them. Okay, so I also use the for loop to iterate through our arrays of variables we've created, which is cat_vars, and I use this block of codes to create this pie plot. Okay, so let me go ahead and click on this so that we can see the full visualization of this plot. So from our primary diagnosis, you can see circulatory was 33.3%, missing is 0.0, musculoskeletal is about 6.0, injury is about 6.7, diabetes is just taking about 7.0%. okay, so take note of this figure because this question is to analyze how diabetes affects readmission, right? That's what we are trying to answer from this question. How diabetic diagnosis affect readmission rate? So you could see that diabetes is just taking 7.0% in this primary diagnosis distribution. So let's look at our secondary diagnosis distribution. At our secondary diagnosis distribution, diabetes is just occupying 11.6% also, right? Then let's go down and look at the last diagnosis, which is our additional secondary diagnosis. So if you look at that distribution, you can see that diabetes, patient with diabetes is just 17%, okay, of our data set. So let's go down and see what I did next. So the next thing I did was to subset for patients with diabetes diagnosis only, because we want to look at how diabetes affect readmission of patients, right? So I just want to look at those patients with diabetes and see their data set. So that was the next thing I did. So to do that, I wrote this block of line of code. So you could see our HSP_DF, and using the square brackets, I identified that I wanted just my primary diagnosis to be equals to diabetes, or when our secondary diagnosis is equals to diabetes, or when our additional secondary diagnosis is equal to diabetes. So I'm saying return all rows of data only when it meets any of these condition. Okay, so this was the data set that was returned, and you can see if you check our diagnosis column, you will identify that either any of these three columns, diabetes must be identified. So if you look at this first row, you see that additional secondary diagnosis is diabetes. If you look at the second row, the primary diagnosis is diabetes. If you look at the third row, so forth, because from our data, from our line of code, we said any of these three columns, the patient must be diabetic before you can return that row. Okay, so the next thing I did was subsetting for patients with non-diabetic diagnosis. Okay, so I also want to get the data set of patients that are non-diabetic, and to do that you just have to add a tilde to your code which you've written previously. It's going to give you the opposite of that code you've written. So before we took patients that were diabetic, so if I had tilde, and tilde is going to give me the opposite, it means it's going to give me rows of data of patients that are not diabetic, right? So that's what I just did. I went ahead to check for the numbers of non-diabetic patients, and I saw that the numbers of non-diabetic patients is 16,212, while the number of diabetic patients is 8,788. So the next thing I did was to look for the percentage of patients that were readmitted. Okay, because we are trying to say, is diabetes a cause of readmission on patients? That's the question we have been trying to answer, right? So let's look at the percentage of these patients that have been readmitted for just our diabetic patients. And you can see that for this data set, remember we have 8,788 patients out of our roll of data set which we had earlier on, and among these patients that are diabetic, we can see that for those that have been readmitted, it's 46% of these patients have been readmitted had diabetes, while 53% that had diabetes were not readmitted. So take note of this figure which we had here also. So what I did was to create a chart to show the visualization of this my finding. I created a pie chart using this block of line of code. Okay, if I go ahead and scroll downward, you can see visualization of our percentage, and you can see that we had a larger portion of diabetic patients that were not readmitted. Okay, so after that I did same thing for our non-diabetic patients, and also to check their readmission, their percentage, how proportional it was being readmitted or not readmitted when you are non-diabetic. You could see that people that were non-diabetic that were readmitted was 47%, while those that were non-diabetic and were not readmitted was 52%. Okay, so same thing, I also created a pie chart for us to visualize our findings. I'll also be dropping the GitHub link to this Jupyter notebook so that you can gain access to all codes I use in writing this notebook. The next thing was to create a table that shows the count of readmitted patients for each diagnosis, not just diabetes this time around. Okay, I use this line of code to be able to create this table using the group by function. I placed in our primary diagnosis, secondary diagnosis, and additional secondary diagnosis, and I want to look at readmit patients that were readmitted for these 3 columns. Right, for primary diagnosis, you can see the various diagnoses that were primary diagnosis and look at their readmission rates. So for the readmission, you can see that for primary diagnosis, circulatory was 1724 for patients that were readmitted, right? While for diabetes we had 394, and we also had other figures. You can just scroll down and see the various figures we had. Okay, let me just give a summary of what my analysis was. Okay, so after exploring the data, I could deduct that about 8,788 patients had diabetes as either a primary diagnosis, secondary diagnosis, or additional secondary diagnosis. This made up about 1/3 of the patients' population. Amongst the DM patients, approximately 47% were readmitted, while 53% were not readmitted, while about 16,212 patients did not have diabetes mellitus as either a primary diagnosis, secondary diagnosis, or additional secondary diagnosis. This makes about 2/3 of the patient population. Among the non-diabetic patients, approximately 47% were readmitted, while 53% were not. From the analysis, we cannot really say that diabetes plays a central role in readmission, as there could be other factors causing patient readmission, but we can deduct that majority of the patients had diabetes as a diagnosis, logically making them occupy a high readmission rate. So that was my results from this analysis I conducted, and you could see I stated it clearly there. So the next question for us to answer was, what group of patients should the hospital focus their follow-up efforts to better monitor patients with a high probability of readmission? So I use the dot head to view my data set once more. Okay, and when I was done with that, I decided to plot a graph that shows the distribution of numerical columns by their readmitted status. So I looked at time in hospital, number of lab procedures, number of medications, number of outpatients, number of inpatients, and number of emergency. So I want to look at how those columns relate with being readmitted or not. So I use an histogram to look at the distribution. Okay, if you look at this graph, you will see our time in hospital for patients that were not readmitted, and you can see that it looks similar to our time in hospital for patients that were readmitted, right? If you also look at number of lab procedures, the graph for those that were not readmitted looks same, or it takes same shape as the graph for those that were readmitted. If you also look at our number of procedures, you can see same thing, and number of medications, same shape in our graph, and so on. Okay, The next thing I did was to visualize our categorical columns by their readmitted status. Also, the first thing we looked at was the numerical columns, right? So now I want to look at the categorical columns, and let's relate it with readmission and see if there's anything specific we can find out from our analysis. So this time around, I used the count plot to plot our readmission in relation to our categorical columns. And let me go ahead and click on this so that we can see all our graphs. You can see for readmitted, we have the pink as no, the green as yes, and for primary diagnosis, you can see how related each columns are together. Patients that were not readmitted for circulatory are a bit more than patients that were readmitted and had circulatory diagnosis as their primary diagnosis. So you can also see same for others. Then people that had respiratory issues as their primary diagnosis, you can also see that we just have little difference within these two columns. Okay, so let's go down. You can also look at our secondary diagnosis and our additional secondary diagnosis, right? So we also looked at glucose test, HbA1c test, and also med change. So you can go through this and data set and get more analysis from this graph. The next thing I did also was to look at their correlation. Are each columns correlated with if a patient was readmitted or not? And to do that, I set our readmission column to numerals, so yes for 1 and no for 0. Then I created this heat map to show the correlation between the various columns. So if you look at this heat map, you would see we have our readmitted as 1, and you will take note that the colors changes as our correlation value changes. 0 for not correlated and 1 for strongly correlated. Then we have minus as negatively correlated and plus as positively correlated, right? So the darker the color, the more correlated the both columns are, right? You can see that our number of medication is correlated to time in the hospital. The higher you stay in the hospital, the more drugs you are going to be saved. Then for our readmitted, which is our major column we are looking at, we can see the columns that were more correlated with readmission was the number of times a patient has been an inpatient. You can see we had 0.21 here, and if I go through this heat map, that is the column that correlated more with being readmitted. Okay, the next thing I did was to summarize my findings from these visuals, right? So from the graph above, I said there are no significant factors that could show what group of patients were more likely to be readmitted, as their distribution and patterns were alike across all categories of readmitted status. However, we can notice the heat map shows a weak correlation between inpatient and readmission. Okay, I went ahead to check the variance of our variable using the dot var method to see the variance between our columns, and I stated that although we can notice there's a huge difference between the variance of the different columns, I would not be standardizing or normalizing the variables as I'll be using classification tree models, because it has ability to describe non-linear dependencies and it does not require pre-processing of variables before modeling. So I'll be ending this video here as this video is already quite long. In our next video, we'll be looking at how I pre-process the features and target variables and the various models that were created. Ensure to subscribe to my YouTube channel for more healthcare data analysis tutorial like this. Also drop your comments and questions in the comment section. I would ensure to reply to them all. Don't forget to share this video to your friends and loved ones. Bye for now and see you in our next tutorial.